right, I'm here with Andrey and Marina from Renca, and today we're going to talk about their geopolymer materials developments as it applies to construction and the future of automating the construction industry. Thank you both for joining me today.
Thanks.
Hello, thank you.
So if you could give a brief overview of your company, tell me a little bit about what you do.
Well, our company was formed in the beginning of 2016 after we met at the Geopolymer camp in France with our Italian partner, Alex. And we decided to create this company to join our efforts in creating geopolymers for various applications, including 3D printing. And as we realized that geopolymers are perfect for 3D printing because of their properties, of their fast setting and good adhesion and others, we started promoting them and trying geopolymers with different 3D printing companies. And since then, we're working and finally have opened our own 3D printing facility, 3D printing factory here.
Sure, cool. And I noticed your material in the past I had seen online has a very fine consistency, it seems homogeneous. And I haven't seen many cracks, although I haven't seen too many of the prints in person. I did visit Geopolymer International in Las Vegas. So they had a couple prints at the World of Concrete event. Can you talk about the differences between geopolymer and regular concrete?
Yes, sure. It's a difference in chemistry. So Portland cement-based products, all Portland cement-based products are hydraulic binders. So their chemistry is connected with calcium, which hydrates with water. And in geopolymer, we have different type of reaction which is a polycondensation reaction between silicon, aluminum, and alkali metals mainly, but also there are different types of geopolymer reactions. Anyway, it's not a hydration process, and that's what makes it totally different from Portland cement and gives it unique properties like a good adhesion. It's a chemical bonding between layers. So even if we stop one day and we decide to continue the next day with a fresh layer, with a fresh geopolymer, we don't need to prepare the surface. We don't need any glues or whatever. The adhesion will be perfect and it will become a monolith. And also it has a very high strength, above 40 MPa and more. And it has a fast setting. In fact, in the beginning, before we started 3D printing, we tried to fight this property in geopolymer. We tried to prolong the setting time to make it more similar to ordinary concrete. But then we realized that this is a benefit, not a drawback. And we started using this feature in 3D printing. So we don't need to accelerate geopolymers. They are very fast by its nature.
That kind of leads into my next question. The difference is somebody who's used to working with a concrete material, how will they have to shift their work strategy and their to-do list with geopolymers?
Well, they basically they change the binder from Portland cement to geopolymer. So they just exclude the binder part with all the additives, which expensive additives usually that go with Portland cement, and they just substitute it with geopolymer. Aggregates can stay the same, and they also exclude water because we don't need water in our reaction.
And the main difference is the geopolymer binders, geopolymer mortar or concrete cannot be made continuously. So it differs it from Portland cement-based mortars, which can be easily pumped, and with the regulation of water amount, you can adjust it. So you have to make a batch mixing of geopolymer. This is obligatory.
Sure. And so the batch mixing, I took a look at the mixer they had at Geopolymer International. Is that similar to the one you use?
Yeah, this mixer was made by our partner, Alex, in Italy. This is a smaller version, but it's not fully automatic. For 3D printing, there is a complete system with different mixers, which allows us to make geopolymer non-stop. So once the first batch is made, the second is already preparing, and then you have like a smooth, with no interruptions, process of feeding your system, feeding your pump.
How does the system become flowable? How does the material become flowable without water?
There is a reagent part, the liquid reagent part, which contains already water inside, but it's a chemically bound water, so it's not a free water.
Mm-hmm. And if normal water was used without any of the reagents, how would it react? Would it just be a complete fail, or would it be less strong?
Yeah, it will definitely reduce the strength. Like in ordinary concrete, if you overdose the water, you will have worse results in terms of strength and durability and stuff.
And here we have like with adding additional water, you will dilute the reagent. You will dilute the cations of metals that you will have inside your reagent, and then you will not get as strong geopolymer network as you can get without this water.
Mm-hmm.
But water in geopolymer system acts like a plasticizer. So we can add additional water if we need to, but really little drops.
Like 3-5% maximum for the total amount. And then during the geopolymerization stage, all the water evaporates out of the system, and there is no chemically bound water inside geopolymer concrete. That's why it's fire resistant. When ordinary Portland cement heated up to 600 degrees with normal fire, the water inside the system of Portland cement is chemically bound, and then it starts to evaporate, and it makes cracks. It cracks the concrete from the inside. Thus, the steel reinforcement could touch the fire, melt, and the whole building collapse. In geopolymer, there is nothing to evaporate, so it can withstand temperatures up to 1,200 degrees Celsius, and you can increase this with the addition of different type of fillers, but normally it's much more heat resistant than Portland.
Yeah, that's a fascinating difference, because concrete takes, the water it's curing forever. 10 years, 20 years, there's still a little trace amount of water left. So in terms of cracking, I imagine that's part of the reason people say concrete always cracks over time. Are there very old geopolymer structures that we can look at and examine if they've cracked?
As Professor Davidovits from France, who is the inventor of this technology, claims, he says that there are many ancient monuments that were made with ancient geopolymer technology. So it's not modern geopolymer, but it's a kind of old style technique. And one of those is Roman cement, so-called Roman cement, which was used in Italy. They used fly ashes from volcanoes.
Volcanic ashes.
Yeah, volcanic ashes. They mixed it with lime, and they got this Roman cement, which still stands for 2,000 years in salty water, with earthquakes, with everything. Another example, which he claims, is the Egyptian pyramids, which were also casted by his. He has written a book and a big work about this, and also some monuments in South America claim to be made with geopolymer technology.
Interesting that it would be so widespread around different places in the world and so old at the same time.
Yeah, because these materials are present worldwide, so there are different types of chemicals that you can mix together to get the kind of artificial stone, because concrete, in fact, is an artificial stone, and the way we make it is only depends on how well developed we are and what materials we have. Portland cement actually makes an artificial limestone because it is made out of limestone. We first evaporate water from Portland cement, then we add water to create an artificial stone back. And with geopolymers, we make kind of the same thing, but we make different stones, not limestone, which is not very strong, not very durable in nature because it has calcium. We make stones more similar to granite and other volcanic rocks, which are more durable and which are stronger.
Very nice. And do you know Professor Davidovits?
Sure.
How did you meet him?
Geopolymer camp, which he makes.
2015.
Yeah, he makes them every year. We met in 2015. And there we met Alex as well. And since then, we visit each geopolymer camp every year. And just the day after tomorrow, we start going to France to the next geopolymer camp in July next week.
Very nice. And how many other people will join you at the camp?
There are about 90 people each camp. They try to make this event small, but very high quality. So they're representatives of science, they're representatives of industries and businesses. It's
so
a very
how
nice
many companies are developing their own product material solutions like yours of those 90? And how many of them are like Geopolymer International looking to purchase your product and use it with their own equipment?
Well, I would say half of the participants are scientific. So it's a kind of university
Academic
students.
research.
Yeah, academic research. About 10 to 12% is the representatives of industries who supply materials like Sibelco, like the Marys and other groups. Vilners, yeah, those who supply raw materials.
In Europe.
Mainly in Europe, and others are some researchers and those who develop geopolymers for certain purposes, for certain applications. Like there was a company who used geopolymer for refurbishing old sewage pipes. Others used, like in Ireland, Bana, UK, they try to use ferrosilate geopolymers. So they're kind of—
Australia, the private company Wagners, they made the concrete, I would say, road for the airplanes. The whole
Interestingly enough,
airport Brisbane was
I think you're very different from all those companies.
There are not many.
Focus.
There are not so many companies that I know in the world who are doing geopolymers, who are making geopolymers for sale, like really commercially.
Yeah, it's uncommon. I haven't seen any other company offering 3D printable geopolymers besides Renka.
Not yet.
So
not so much.
When did you start Renka? After the 2015 event?
Yeah.
At 2016 in January, we went to Irkutsk to APISCOR facility when Nikita asked us about making a geopolymer for 3D printing. The 3D printing was actually just emerging technology at that time, and we were laughing like, wow, 3D printing, really? Concrete, are you sure? And then we did trials. You might see it on the internet, on YouTube, there are a lot of them. And they were successful trials with Geopolymer. And then it started to develop, we started to develop 3D printing mortar for Geopolymers.
Very nice. So Renka started from the beginning with the intention of 3D printing, developing 3D printable material.
Not exactly. It happened thanks to APISCOR, I would say, because we were studying a lot of applications for Geopolymer, like we were aimed to more construction market, yeah, and try to substitute the Portland ready-mix concrete.
Yeah, at first that's what I had assumed, because most material companies, you go on their website and they're selling all kinds of concrete, and then you find some bottom page where it says innovation. Look, we're doing some 3D printing too. But if you go on your website, it's the top first thing is 3D printed geopolymer.
Yeah, so, where it showed its properties at best in 3D printing. And then you just find the niche markets for geopolymers. So you don't need to build 25 stories building with geopolymer concrete, because it will cost you much more than using ordinary Portland cement. Now, yeah, but when you target the markets where the properties are important, and to achieve the same properties based on Portland cement products, you will have to pay 2 or 3 times more.
Sure. And when you got started, the goal of the company was to work with geopolymers, and 3D printing, you're saying, was kind of a natural progression of the company as you were exploring the use cases.
Yeah,
right.
Exactly.
And it's still the same. The geopolymers are the main target of our company, and 3D printing is just one of the applications that shows the properties, shows the possibilities, what you can do with geopolymers.
Cool, very nice. And when it comes to construction projects with geopolymers, large scale, like, I'm sure, are you planning on building any houses with your material?
We're printing a house right now.
Wow.
With our geopolymer, yeah, the first private house. Then we have already several pre-orders, I would say, of people who want to build their houses, private houses, also with geopolymers, with 3D printing. But before we also have done some use cases of geopolymers aside from 3D printing. We made a pedestrian bridge in Moscow region. We have also made several trials in our native city of Chelyabinsk in the Urals, where we have used geopolymers in ordinary construction, in multi-story buildings, for ceilings, for parking spots, for foundations.
Mm-hmm. So with the house underway right now, are you using the signature red color that you use so often?
First, we tried red, then we decided to go to the natural color, which is a dark gray, closer to black one.
Mm-hmm. People like the red. I guess it looks like Mars, or what's the choice there?
Okay, we will make some panels with red for sure.
In fact, you can add any color to your geopolymer and make it yellow, orange, whatever you want.
The house, how many square meters will it be?
It will be 150 in 2 stories.
2 stories.
Yeah, yeah.
Well, 1.5 stories, I would say. It's not.
So is it like 3D printed concrete where you have an inner layer, an outer layer, and then some kind of columns that you pour in later with rebar?
We have, let's say, a panel which has a layer, then this intermediate layer of a kind of wave, which helps us hold the structure, another layer, and then we have another chamber, a little bit smaller with the same arrangement, which will be used separately for thermal insulation. So there will be thermal insulation in the outer chamber, and then there will be also some of the thermal insulation in the inner chamber, but part of it will be used for structural concrete and reinforcement too, and also for communications like pipelines, electrical wires. Stuff.
So no rebar, or where's the rebar?
Actually, our engineers have calculated all the loads and taken into account the strength of the concrete and the shape of the wall, and that it's a small house, it's not a multi-story buildings. They assure us that we don't need reinforcement inside. On the 150
square meter 2-story building, you don't need reinforcement?
Nope.
No.
Wow, that's so great.
It will act like when you make bricks, you don't need reinforcement for bricks, for example.
Yeah. So would the floor be floating, like connected to the slab or the ground level? Or is the floor connected to the wall structure? And is the wall structure continuous?
Well, we have, because of the dimension that our printer can print, we have to cut the whole wall into pieces. Mm-hmm. And the first piece is connected to the slab, and the second one is will be on the top of the slab. And you don't need any additional connections, any reinforcement, any connection to the basement, and so on.
So you'll have the first level, and then a floor, ceiling, slab, and then the next print. The printer will rest on top of that.
Actually, our model is printing panels, like we have panels in the warehouse. So
offsite.
We are not going to warehouse. Site.
Wait, you said on-site or off-site?
Offsite, in a factory.
In a factory, in our warehouse, because we tried 3D printing on-site in Siberia in 2018 with Gazprom Neft. And when you have like 3 degrees Celsius in the morning, then you have rain, then sun, then wind, and plus 17 during the day.
It's much complicated to control the mix, everything to control.
Yeah, even if it works, it's not pretty.
Yeah, it's absolutely not pretty, because once it gets hotter, your mix starts to get too sticky, and one is more cold, and then it goes too fluid, and you have not a nice surface.
Sticky isn't a word I've heard applied to 3D printed concrete. Is that unique to the geopolymer mix, kind of flowing through the hose if it's very hot?
Sorry? So, can you repeat the question?
When you're working with 3D printed concrete, when it's flowing through the hose, sometimes you get clogs in the hose if the aggregate's large, or if too much accelerant, something like that. Would the hose clog for similar reasons or different reasons with geopolymer?
No, you can comment.
Yeah, it's practically the same reasons like with Portland. If you overheat your system or your mix is too sticky and your pump gets higher pressures, higher pressure means higher temperature, and temperature accelerates the reaction both in Portland cement and in geopolymer. So if it's too hot, it gets it sets much faster. So you get your
and I would say not the hose plug, but the rotostator stopped because of the material inside is already set. Then you need to replace rotostator. So
you need really to control your pressure inside your rotostator all the time, and you need to control the temperature. That's what we're doing constantly. So the mix should be really prepared in small batches so that it doesn't set inside your hose, inside your rotostator, so that you have, let's say, constant consistency all the time.
Very nice. So you're a part of the American Concrete Institute as well. What's that about?
Well, it's there are two committees connected to 3D printing and additives. So I was just part of this and taking knowledge from them.
And is it still active or not so much useful? Not really.
Well, I would say it's more useful when you have projects related to the standards that are in the United States. So it is really useful when you have some project which is local. And when you're in Europe or abroad, it's not that, I would say, applicable.
Yeah, the standards aren't very sensible at the moment, and people are working on making new standards, but they haven't been implemented yet. Hopefully they are soon, but I see lots of projects attempted and shot down because it's too restrictive for them to build, at least here in America. So
the standards need to be paid by someone. Yeah, you have to spend a lot of money. It's a whole world of developing standards, a lot of influencers, a lot of those who want you to issue the standards, a lot of those who are against the standard and so on. But actually in Australia, there is a really good situation concerning application of geopolymers, because in Europe and mostly the United States, you have a standard for concrete where it is stated that you have to have Portland cement, at least a certain amount of Portland cement inside your concrete. In Australia, there is a performance-based standard that don't care what you put inside your concrete. When they meet the requirements, they have strength, they are free those cycles, water resistant. Nobody cares what you put inside. And that's why in Australia, there is a good market for geopolymers.
Here in Russia, we also have a standard which state that concrete has to have Portland cement inside, but we can use geopolymers if, according to the local standards of the organization, not the national standards, if the constructor, the company which is making the works, will take responsibility for the material as well. In this case, they can use, at their own risk, they can use this material. Also for private housing, you don't need any standards, so you can build your own house with whatever you want.
Especially if you go east, you can do whatever you want if you could survive the winter, right?
Yeah. It's up to you. You can make it out of sticks and paper if you want.
So you need a lot of insulation in those walls.
Yeah, that's why we made our walls 2 chambers to make heating and thermal insulation according to the local normatives.
Climate.
To the climate, yeah.
So what's the future for Renka?
Well, we tend to make this 3D factory to let's say create showcase and make different projects which will be really challenging, like some architectural projects, make different shapes, different structural elements.
We are now developing the recipe, the mortar that will be set at the nozzle, and we can make very small objects, really 3D printing, because now what we do, we are constantly going up and we do 2D printing, like the companies that using accelerators.
Sure, like 1K
nozzle.
versus 2K. 1K you go straight up. 2K you can do an angle or a convex.
Exactly, without additional sand and whatever.
That's the next step that we
Yeah.
want to make. And yeah, and then we want to participate in infrastructural projects and different architectural projects which will be really interesting and challenging for the technology.
And
So
for
you're 3D
geopolymer,
printing- Sorry.
yeah, sorry. And for geopolymer production, we are trying to expand the market, and we're looking for partners around the world and trying to establish it everywhere. So the geopolymer could be available in any part of the world, which is ready-made, and you can just purchase it online or locally.
And you just set up the factory?
Yeah.
What does
All
that
the raw
look like? You got a
materials.
printer to be able to test the material yourself and showcase, demonstrate prints, robotic arm or gantry?
Well, both variants are possible.
Now we use the robotic arm.
For me, it's just easy to use robotic arm, because when we started in 2017, actually, with ABB, they were the first company who replied, and there was no additional software which can handle 3D printing, and they're really cooperative guys, and that's why we just decided to buy our own printer ABB. And actually, you can print geopolymers with any type of printer, and we have experience printing with gantry type, like cobalt type printer.
With Spetsavia, which you maybe have seen in
Yeah, this
AMT.
silly
AMT, yeah. Exactly.
AMT, yeah.
We actually are cooperating with the Polytechnical University in St. Petersburg, who bought their printer, small printer from AMT, and we help them to make it work. And we supply them with geopolymers, and now we cooperate with the professors and students.
And they do actually a good job of studying the properties of 3D printed wall, like thermal insulation, the recent publication by this university, June. And they do a lot of, actually the universities, the academic researchers are helping 3D printing industry a lot. For them, it's a new technology which they can study, which they can get some degrees and so on. But for us, for industry, it's a huge advantage, and you don't need to spend time for understanding what kind of, what shape of the wall you have to have in order to meet the requirements of thermal insulation, in order to make it strong, in order to not fall apart and so on.
Yeah, I definitely respect the academic research because it's so expensive. Private companies can't always afford to experiment so much. The gap is when people pursue things that they think are scientifically cool without thinking about the business case. And what I'm really interested in is construction, particularly residential construction, where the ROI, the cash flow, these are like the predominant factors of making something applicable in the real world rather than the academic setting. So the academics are great, but they're not making products for the world. They're making solutions for people like you to bring to the world in a marketable way that can hopefully
they're making fundamental research
profitable for you.
Yeah, so they're doing their job, and we try to, like, say, forward them in the right direction so that they can help us, not doing something useless, useless research, but something which can really be applicable in the real world.
We always look into geopolymer or any science that we have, that we got, whether we can scale it, whether we can make it industrial, whether we can produce it industrially, whether we can 3D print buildings, not just the small size, but the big one. Can we mix a certain amount of material with the mixer? What kind of mixer we should use? And our partner Alex started to develop this mixer in 2016. Yes.
After the first trials with Apiscore,
we realized that when you want to build a house, you have to have a big batch mixer, and there is none on the market right now, which can prepare geopolymer non-stop.
By non-stop, you mean basically multiple batches going at once?
Right. Yeah. And without human factor, so you don't need to control the recipe, whether they put necessary amount of material and so on.
is the workflow with your system, the mixer pump system, the same number of people as a 3D printed concrete system?
Yeah.
After the material is printed, do you spray any kind of post-print to help it cure?
Curings, yeah, we do spray curings just to be sure that nothing will happen. And the most important, what we do is not to move the structure.
When it's still soft.
Yeah, when it's still soft, because the geopolymer structure at the early stage is very gentle. And if you move it physically a little bit, it can make cracks.
Mm-hmm.
But there are no
Shrinkage.
in
How long do you
geopolymer.
wait?
Several hours.
Yeah.
Just a couple of hours to make sure that it's already strong, because first of all, it makes a crust on the surface and the internal part is still soft, and that's when you shouldn't move. If you move, this crust will crack and will never be repaired again. So it's not very nicely looking.
Very interesting. And so is there a tarp over it at any point? Do you want to maintain humidity, or
No.
the water's all leaving so quickly?
No, we don't need to maintain humidity, unlike Portland cement, in order to avoid the cold joints. Here we have an adhesion in between layers, thanks to the geopolymer interaction of atoms.
So you can move the object within a few hours, and then how long do you have to wait until the dehydration process is complete?
There is actually, you can, let's say, move the object and start using it in about a week, because this is a fast setting geopolymer, but it will still continue gaining strength after 20 days. It will gain even more strength in 50 days and then in 90 days. So it's a continuous process which will continue up to 180 days and even maybe more, but there is more research that's needed.
So the difference was
long-term.
There's no water molecules in the geopolymer, right?
No, water is not in a part of the reaction, so we don't need to keep it humid after it's cast. But we need to put curing to avoid too fast evaporation of the water, which was inside from the beginning, so it doesn't create any disturbance on the surface. That's the only point. But once the water is evaporated slowly with the help of curing, there is no water anymore in the system.
As opposed to concrete.
Yeah, which has
7 days curing at least, or you need to add some special additives that will decrease this period of time to 3 days or something like that.
Have you thought about? Sorry.
Sure. In Portland, you have these particles of cement, which have each particle has to react with a part of water. And if there is not enough water, not all of your particles of cement will react. So you don't have the designed strength that you have designed from the beginning with the composition of your mix. So you will lose.
You will have unhydrated cement inside the concrete.
Yeah, and it can create some problems like, for example, sandy surface, dusty surface, which becomes not very nice, and then it can crack superficially.
So as your company, as more people begin using geopolymers, and you need more and more materials, some things like fly ash are very useful, but a byproduct that's maybe not scalable. Are the components of geopolymer scalable?
Yeah, absolutely. We use fly ash here because we have it in abundance. Like one power plant creates from 3 to 5 million tons per year of this fly ash, which is more than enough for geopolymer production. And there are several, plenty of this kind of power plants here. The same situation is in India, in China, but not in Europe. In Europe, Alex has done, he switched to other sources of materials, like different kinds of clay materials, byproducts of clay materials. So there are plenty of raw materials which can be used in geopolymers. You only need to know the chemistry and mineralogy and how to use this and combine these different materials. So
Alex is able to replace the fly ash with clay?
Sure, he has already done, and there are different kinds of geopolymers, if you look at the book of Professor Davidovich, there are different, let's say, subsidiaries of geopolymers. They can be fly ash based, based and rock based. So you can use minerals and phosphate based. So there are different kind of families of geopolymers.
Yeah, that's fascinating. And what's the family of geopolymers that you selected for your product?
Several.
Okay.
Depending on the application, we use several types of products and raw materials.
So we use fly ash based, clay based, and rock based. We haven't used phosphate based so much yet, but these three we are using a lot because different applications of geopolymers require different properties. For example, some of the applications cannot be done with fly ash based geopolymers.
When you want to talk about innovation in concrete, a lot of the old guys will say stuff like, there's only 8 ingredients and we've tried all the combinations. There's nothing new. Is that, it sounds like Professor Davidovich doesn't have that opinion.
He's a chemist. He is not a construction guy. He came from polymer chemistry and he has a different point of view, I would say, a different angle. And he created geopolymers trying to substitute organic polymers, which are flammable after some dreadful fires in France when some students have died and because they were suffocated from the gases emitted from the plastics. So he tried to substitute plastic and make it not flammable. And when he started his research, he realized that only minerals are absolutely non-flammable. So he decided to make a mineral polymer and he called it geopolymer.
Sure, so any mineral can be a geopolymer. And I mean, how many different minerals are there?
Plenty. So it depends on the raw materials that you take. And then you make artificial minerals, artificial stones.
You can use volcanic ash, for instance, if you have somewhere in Africa, and you can get some salty water from Natron Lake and mix it all together and get the geopolymer, kind of geopolymer, but the idea will be the same. So depending on the geopolymer is like 0 kilometer material. So depending on the location where you are, you can find the different types of raw materials underground, or you can find the byproducts that are generated by the industry. And you can, depending again on the state of these byproducts, you will need to grind it, or you will need to calcine it.
Or you can take it as it is, ready.
Or you can take it as it is and just mix it in the dry mixer. Then you add reagent, and then you get a geopolymer binder. And actually, the concrete, the construction application for geopolymer is just one of these small ways where it can be applied. So it just the bottom layer, I would say, geopolymer technology, it can be applied in composites. It can be applied to encapsulate radioactive waste, which we actually do here, and a lot of
ceramics,
yeah, when we can make low temperature geopolymer bricks without the need of heating and using just the heat from the sun.
You can use geopolymer to hold back nuclear radiation. Is there any way with 3D printing that it benefits maybe you can create cavities within the wall or something to make it more helpful, or I don't know?
Well, actually, there is a technology of mixing this liquid radioactive waste with a binder. Right now, they're using Portland cement, but when you substitute it with geopolymer, you make it last really like 10 to 100 times longer.
Interesting. And then that traps it?
Yeah.
The cations of radioactive materials are trapped inside. There was a study for the Fukushima plant in Japan. They studied geopolymer to encapsulate the material, the radioactive cations inside the geopolymer matrix. Actually, the geopolymer matrix is a good trap for those guys. If you made everything right way, mixing, and then you can get a very long-lasting structure.
And it also works for toxic wastes. I mean, like heavy metals and arsenic and mercury, which are present in some of the wastes, which are now
fly ash, for example. A lot of these bad guys.
When you say the matrix, are you referring to like a chemical structure in the geopolymer that forms if you print properly and mix properly?
Yeah,
What's that
exactly.
structure?
You have three-dimensional network of geopolymer, like in any polymers. But unlike polymers, instead of carbon inside, we have silicon and aluminum in this three-dimensional network.
And then it attracts and traps inside the matrix. There are kind of spaces where it traps the heavy metals or toxic metals and prevents it from leaking into the soil, into the water, and so on.
And the spaces are larger than an H2O molecule, so it doesn't trap the water? Wow.
Well, yeah, and when you create a geopolymer structure, when you create a geopolymer concrete, we call it a mesoporous structure. When you have pores on the surface, but they are so small that the water molecule cannot penetrate inside, so it's kind of waterproof.
Okay, but the water leaves it's waterproof and holds the water in the structure, or
no, after it's absolutely completely hardened, it becomes waterproof. When it's still fresh, of course, the water goes out. Yeah.
Chemistry is a very weak suit of mine, as you can tell, I'm sure. But the materials, would you say they've experimented with all the minerals, Davidovits and his team, or are they still exploring all kinds of different stuff all the time? Is it unexplored mostly?
Well, actually, there is a huge community, scientific community worldwide who are studying geopolymers, and their publication not only by Davidovits, but also by other institutions worldwide. And they all study different matters. They all study different approaches, applications, materials for geopolymers. And there is a lot of that has been already studied, but I think that there's still much more to be investigated.
That's good to hear.
Another point, you need to make it applicable and scalable.
Certainly. It's nice just knowing that there's still lots to explore is reassuring enough, especially considering there's so many different people experimenting with it. What developments might they find in the next 5 years or 10 years that you're looking forward to?
Well, certain, let's say, ameliorations, I have to say it in English. Okay, upgrades for geopolymers, like, for example, making a one component geopolymers instead of two components that you have now to avoid liquid reagent. There are several attempts and people are working on that. And we would like to get the result if it's possible, of course. And then certain kind of additives, which would help us regulate the flow, the setting time, and so on, easier, like in Portland cement, for example, because Portland cement additives don't work in geopolymers because the chemistry is totally different. So there is a huge set of chemicals or minerals that still need to be investigated so that can work in geopolymers.
So the 2K mix that you are going to start using soon in your factory, do you have any idea of what kind of overhang you'll be able to achieve with that?
What kind of what?
What kind of overhang or cantilever or what angle you'll be able to achieve printing?
We'll see. We'll see. We can accelerate the setting very fast, so it can set in seconds, and then we just need to experiment. The main problem that we have right now is the equipment that we need to develop to feed this mix. So we already have completed successfully the tests in the lab, and now we are developing these equipment for the nozzle.
To test it already industrially with a 3D printer.
I hope in a couple of months we will complete it and start printing.
Yeah, in a lot of ways, all innovation is the same in that, like, if you're working on a car, maybe the engine, you made it so strong, it's like 1,000 horsepower engine, and now the tires won't spin, so you have to upgrade the tires, and then you have to upgrade the suspension, and then, so everything is like the machine, the material, the software, like it's all being improved all the time.
Yeah,
exactly.
And you're the people working on bringing that to market. So it's cool being able to hear kind of like the bleeding edge of innovation as you're figuring these things out. You have the house project. That's not in the States, is it?
No.
No.
Do you have
it's
any?
Our own house.
Mm-hmm.
Yeah.
The
because
Geopolymers
of the
International guys were talking about a house with you guys.
yeah, they're trying to print the house.
We actually planned to start last winter, this winter that has passed, but then it was postponed, and now with this situation, I don't know how we can further cooperate. We'll see.
You said you're printing your own house that you'll live in?
Yeah.
Wow,
Yeah.
that's awesome. I don't think I've seen that done before.
Yeah, well, we want to test all mistakes on our own skin.
And we actually calculated the cost of the wood right now, and the house and the wood cost us a fortune. And then we decided to make a 3D printed house, and it will cost like twice less.
Very cool. So did you make the 3D printed file yourselves?
Yeah, sure. Well, with the help, we made a G code with the help of our friend, and he makes it using not standard method. They use Fusion 360 to generate G code, because you need to adjust the way the nozzle will go and the thickness and so on. And then I had to study how to operate the robot, and now we're just printing.
Yeah, and of course we have our engineer and architect in one phase, who made our project first in the wood, and then he agreed to participate in this idea of 3D printing, and he made all the calculations, all the projects, all the drawings in 3D Revit program.
Yeah, it was funny. I recognized Alex on your website. I guess I've interacted with him on LinkedIn or something in the comment sections, but I had no idea he was working at Renka.
Yeah,
we established in 2016.
And since then, even now, we cooperate. It's like a exchange of knowledge all the time, forth and back. And sometimes we send him materials from here. Sometimes he sends us some materials, so gives us hints what to use.
Do you have kids?
Yeah.
So they'll live in the printed house with you?
Yeah, of course.
Sure. Are they excited for that?
She's a teenager. How can you be excited when you're a teenager? Everything is
your parents' stuff isn't that cool. Your parents' work is kind of boring at that age. But
leave me alone.
While you're printing it, you should get lots of phone videos, and I'll post it on social media and stuff, and we can the print process is, I think, people's favorite part, to see the progress from like an empty build site. The layers go up, and then all of a sudden you have a whole home.
We have our own channel in Telegram, and we have it in VK
and LinkedIn.
And now we start posting on LinkedIn also.
Cool. So you can follow our page.
Also Yandex.Zen.
Whatever.
Yeah, unfortunately, it's not so easy to post in Instagram right now or Facebook, but
that's why you should send the video to me, and I'll tag you, and I can post on Facebook.
Yeah, sure.
So when you were designing the house, what considerations did you make? Because you can print it in any shape, design, whatever you want. How did you make it custom for yourselves?
Well, first we chose the design of the house according to a Finnish project. We took a project by from Finland, because they are have a similar climate, and they're the best in thermal insulation in making projects for this type of northern climate. And we liked the appearance. And first of all, we made the project in wooden framework with a lot of thermal insulation. And we got the calculations. It's extremely expensive if you want to make it really in a good
the right way
in good quality. And then we started adopting and adjusting this project to 3D printing to make it the same project, to compare the costs, so that it's a real one-to-one comparison.
That's amazing.
With the same thermal insulation, with the same configuration, and with the same project and the same square meters, but in two different types of materials and two different types of building techniques.
By the end of this construction, we will publish all the calculation, all the comparison on our website, so everybody can just take a look and compare themselves.
The first one you already finished, right?
No, we're still in the process. We're right now in the process.
I mean the stick-built version.
No, we just made the calculations and decided that we don't want to make it.
Okay. You didn't actually build it.
No,
No.
Okay,
We decided to switch to 3D printing.
yeah. And
No, but we have a price tag for that.
construction
decided to-
estimates are so difficult to make. Even your estimate was too expensive. It may have cost 20% more than that even. Who knows?
Yeah.
Well, we decided to buy not the fish, but the fishing rod.
Mhm.
Robotic.
Robotic fishing rod, yeah.
And now you're
Instead
having to
of that-
modify your fishing rod, I imagine, a little bit, making some
Yeah,
customizations.
made some customization, right?
It will take a little longer because now we have to work with 3D printing and so on, not to just order, let's say, a set of the house and invite builders who will make it in a wooden framework, but it will be 3D printed and it will be concrete, which makes it a little bit more reliable and durable.
Yeah, a lot of things are to be considered, like a connection in between panels. So when you're in Africa or somewhere in a hot climate, there might be not an issue. But if you are in a cold climate, when it gets minus 30 degrees Celsius in the winter, you will definitely don't want to have some fresh air in your kitchen. So when the panels are connected, so you have to make it completely sealed, and not only sealed, but it shouldn't allow the cold air and the cold to go inside.
Yeah, and you'll need also to consider your the structure of your walls and your panels, so that you don't have these bridges of cold, because concrete can transmit cold very well as heat. So you need to avoid straight concrete lines, which will go all through your house. You need to make them either longer, so you need to make a special shape, or you need to block the passage with some thermal insulation. All these solutions we now have to design from the beginning with our architects and engineer. So we work, also we try to consult civil engineers. We have a lot of family members who are civil engineers, so they help us a lot, of course. They support us and help a lot to solve some technical issues.
I'm sure that was very helpful.
Sure.
It's always interesting seeing who's the leadership of a company. A lot of times a CEO might have no technical experience, but you're an engineer, right?
Yeah, I'm an engineer.
That's great. I love to see engineers as CEO because they actually understand technology and like, especially at a company that's focused all around technology. How can you make decisions for your company if you don't understand?
Exactly. Yeah.
But yeah, that's a cool thing to see. And another cool thing to see is that you might be the first founders to live in your own printed home. So that'll be huge, I think. I haven't talked to anybody that actually lives in a 3D printed house yet. There are some Airbnbs. Some people were supposed to move into them, but I haven't seen that anyone's actually moved into one yet. So we'll see if and when that happens. Maybe it'll be the first.
Yeah, we will make some, I don't know, YouTube channel where we will post how we will live in.
And we also want to leave the walls undecorated, so that people see that it's really
At least some of the walls.
Internal and external, so that people see that it's a 3D printed house.
And inside the walls, we want to implement the best of geopolymer technology, not only the structural material, but also insulation, which using geopolymer binder and some plasters made of geopolymer, which reflects the sunlight during the summer, for instance, and reduce the inside temperature of the house so that you can save cost on air conditioning, and a lot of technologies, a lot of features that can be implemented here. And we are just discussing with Alex which are the best to implement in our house.
So yeah, in our house, like it's a test ground, and we want to try everything on our own example, and to understand what we're actually proposing to people, what we're actually selling, to test it first, understand how it works, if it works well or not, and then you can really prove to the people that it's working and how it's working. They can come and touch and see, and see that you're still alive. There is no danger in it.
Hazardous products, right, and so on. Oh, you use byproducts, you use waste. Oh my God, it's so hazardous. No, it's completely.
We made all the tests,
Yeah.
of course, where we don't want to risk our lives. So we are testing, we're making careful steps, really consider what we're doing.
Yeah, it's always interesting to hear people think something, this material is good, this material is bad, but then in the long run, at the total lifetime of the object, maybe it's not what people expected. So that's not something I try to pay too much attention to because I don't understand it so well. But I think living in your printed house and printing it, knowing that you're going to live there will give you kind of an extra motivation on the long days where it's like not just a project you're going to leave and finish, you're going to raise your family there. And so you'll put the extra effort in that you need to be on the cutting edge and doing something brand new. I mean, especially since you know you're going to be experimenting with stuff. What are some of the experiments, like you mentioned, this plastering, what else?
Well, internal paint that accumulates heat so that you don't need to spend so much on your heating system
Like a battery.
in winter. Yeah, and also we want to use thermal insulation inside the walls, which is actually waste of polystyrene bubbles. But when you cover them with Geopolymer binder, they become absolutely fireproof and they become mineralized. So the rats and mice and other rodents won't eat them. The flame cannot touch them, so they won't emit fumes or burn or whatever. And polystyrene is one of the best thermal insulators in the world still.
What's the thing that Renka needs the most to grow the fastest?
Well, we need, I think, the help of programmers right now to work with the G code, and we also need some help.
Qualified laborers.
Yeah.
It's in 3D printing industry, I think this is the most biggest issue that we have. We don't have any personnel that are qualified enough to work with 3D printing technology and with Geopolymer either. So you have to rise up your people.
That's why we work also with the Polytechnical University. We work with the students. So we try to raise them up. And when they finish the university, we will try to hire some of the best of them.
Yeah, I think ultimately part of the dream is making it really easy to use your technology so that people can not require much education or skills. And then you increase the labor force, not through training, but through making the process simpler. But the people to make the process simpler, that's a lot of hard effort. And those people are hard to find. Where do you find those people? Are academic settings, outside of academic settings, the people really willing to like do the grind and the sweat, the blood, the tears?
Well, actually, it's just a coincidence when you meet people on your way. We are in construction since 2008, so there are a lot of people who are in construction that we know, and many of them are really fascinated by 3D printed technology, and they offer their help by themselves. For example, our friend, he has a construction company and he offered his help with his engineers.
And he was my classmate.
Yeah.
Maybe some of those people are listening now and they'll reach out and help. Hopefully.
Yeah, probably. Yeah.
We are open to any help and cooperation, and that's here. If you're interested in Geopolymers, so you are welcome. You can write us email and we will definitely answer you. Just, you may ask, what is Geopolymer, and we can help.
What email should they reach out to? On your website?
info@renca.org.
Cool, and the website will be in the link in the description as well.
Okay.
So the team right now is you two and Alex?
Yes,
as the founders.
The founders, and we have also a couple of people here in the factory.
Yeah, we have qualified technicians for working in cement industry, in cement lab and concrete lab since 2011.
Yeah.
And we have qualified labor as well, and unqualified labor as well, of course.
So you're not seeking investment at the moment, or you are?
But actually, we are seeking for grants to develop this system for two-component printing.
Cool.
And I would say we are more seeking for customers and partners.
What are some objects you're excited to print with the 2K capability?
Well,
Columns. I think columns with this pilastra, kind of.
you mean the top of the column?
Yeah.
I don't know the name in English, sorry.
Like an iconic column or the fancy designs with the...
It can be fancy or just functional.
Yeah.
I mean, we already have a kind of request from a bridge construction company who are making bridges for the roads, and they have a big headache with making this top of the columns because they have to use a very complicated framework for that, which is very expensive and requires a lot of time and labor. And they would like to avoid it thanks to 3D printing technology. So this is one of the functional applications for infrastructural projects. Others can be decorative, like can make any kind of decorations with 3D printing technology at no cost, almost, compared to frameworks again and handcraft. And also we were cooperating with an architect who wanted to make a sculpture back in 2018. And at that time, we couldn't achieve this goal because we didn't have this two-component mixing system. Now we would like to continue working with architects for some really nice and good-looking projects.
Awesome. And back to your house for a minute, that'll be printed off-site as well?
Yeah.
What size will each panel be or section?
Actually, there are different sizes, but we calculated and cut the house the way that we can use our hardware that we have here in the warehouse, like forklift, and then we can use the transportation system, which I use for normal ordinary prefab panels. So it shouldn't exceed 4 meters in any dimension.
4 meters is big.
Yeah, it is big.
So from your factory, it'll be lifted onto a flatbed and then lifted into place on site.
Right.
Is that with concrete, a lot of times in transportation, it's challenging logistically, it's rattling around, there might be cracking and stuff. Have you transported many large geopolymer objects yet?
No, not yet.
But the system of transportation of big prefab panels is already well established, and we have good transport trucks for transporting panels for one big construction company here in Moscow, and it transport panels with windows already installed so that the glass shouldn't be broken. And I think the glass is much more fragile than Geopolymer. Yeah. So if they manage to transport this kind of panels, they can transport Geopolymer panels as well.
Does Geopolymer have better tensile strength than modulus of elasticity?
Well, actually, this all depends on the mix design. You can make your super high performance concrete both with Geopolymer and Portland cement. It only takes much more additives and chemicals in Portland and costs than in Geopolymer. It all depends on the design of the mix and what you want. Filler. Yeah, it's just what you want to achieve. We don't need a bomb shelter here, so we won't need only strength for small house. So we don't go above 40 MPa of strength. Even that is too much. We don't need more than 25 MPa actually for such kind of construction.
Mm-hmm. Would a material and system that could print outside better be appealing to you?
Sorry, can you repeat again?
So as we talk about different upgrades for the material, the systems, would it be preferable to have a system that can print outside nicely? You mentioned you tried that before. Would you prefer an outdoor system if it works really well?
Well, the next step, I think we will try to make some continuous tracks for the robotic arm to be able to print outside on
larger
site.
volume.
Yeah.
The big challenge is the weather and all the stuff you were talking about earlier with the outside, but maybe.
Yeah, but I think with this implementation of this nozzle and the fast setting geopolymer, we can solve it. When you inject the accelerator at the end of your nozzle, and you will get the setting, the desired setting, and the rest of the mix can be made in advance, which is not affected by the temperature and whether it's hot or cold.
When you used the 1K mix, did you have some kind of agitator at the nozzle head, or
No, we just go straight from the pump.
And is it the same with the 2K, or now you need to have it evenly mixed in?
Yeah.
So it still just straight flows through the pump, and the accelerant is included. There's no hopper.
No, accelerant added at the end, will be added at the end. So we will see how it will be realized. So
still in development.
We don't have a finished solution right now. I think in a couple of months we will have it for sure.
It would be less fun if it was finished now.
Yeah.
Yeah.
But I trust in him. He's a mechanical engineer.
Is that
funny?
Do you guys have like clear role separations for responsibility?
Yeah.
I do all the dirty job.
And I do most of the talking.
No, she's a database for the technology. She knows about geopolymers a lot.
So I have my degree in economy, so I do all the finances and communications, but also I love chemistry. That's why I went deep into the geopolymer chemistry. It's like a hobby.
Is it common in Russia for husband-wife teams to start businesses together?
No,
it's like everywhere in the world. So it's more like, I would say, no, it's not a common thing anyway, and it's not an easy task. Also, you need really to be on one wave and know how to manage. But there are a lot of benefits when you work together on one goal, and you're really involved in it, and you don't need to, let's say, bother that your wife is waiting for you at home at 6 o'clock in the evening and you have to finish fast. When you're both working on one goal, you understand each other, you support each other. That's
very nice. The only downside, I guess, is there's no escape from work. So you go home and you're just trying to like relax, watch TV. It's like, oh, maybe we should add this material.
Well, yeah, actually, we are workaholics, so we don't like to relax so much.
So I only ask because the APIS core team is also husband-wife team founders.
Yeah. Just a coincidence. Not every business in Russia husband and wife.
Yeah, it's not super common, but I think having separated responsibilities makes it better if one person does engineering, the other person's doing finance and communication stuff. I think
it's like a puzzle. It's like you supplement each other.
Yeah.
Very nice. Is there anything that we left unsaid?
Let me think about it. We said so much today.
Unfortunately, we don't have Alex with us today, so he's on another meeting.
Yeah, but he's really a database, so he has another role. He helps us a lot with the chemistry and mineralogy.
Yeah, he's a mineralogist, and he knows everything about minerals. And it really helps.
He saves a lot of time for our work. So when we have new materials or when we have some issues, we just make kind of video conference, and just chat in chat in writing, and he gives us advice immediately, and it saves us months of work of tests.
I think I'll have to read Professor Davidovic's book, and then maybe we'll do a Renka round 2 podcast episode with Alex, and I can learn a little bit more about. But I think I need to read the book first so I can understand.
For sure.
Be prepared. This book is very, very technical and very, very specific. So we read it once. We didn't understand more than 5%, I think. We read it twice. And now we just return to it to certain chapters when we need to understand some parts of Geopolymers, how it works. And still every time read.
You won't have to understand it well enough to do it. I only have to understand it well enough to talk about it on YouTube, so it's a lot easier.
Then be careful, because a lot of in academic, a lot of stuff when they claim that they make geopolymers, but in fact they make alkali activated material. When you read the words like activator, we get strong alkalis like hydroxides and so on. So you will definitely have the wrong direction. And geopolymers work with user-friendly solutions. So you can pour your hand in the reagent and nothing will happen. And geopolymer is completely different from alkali activated materials, because in geopolymers, instead of alkalis, you can use acid as a reagent. And you cannot make alkali activated slag with acid. So it's absolutely different technology, and there are a lot of misunderstanding. People think, well, they have fly ash slag in their mix and they
alkalis.
use an alkalis. This is the same. It's not the same. It's completely different.
Chemistry is different.
Yeah, you can go to the YouTube of Geopolymer Institute or on the website, and there is a short video why alkali activated materials are not geopolymers. They
So if you put concrete in water, the pH of the water goes up if you put concrete in water, from what I've heard.
If you have a completely set geopolymer with a good balance between all the ingredients, you get a complete system and nothing leaks out.
No efflorescence, no white things on the top.
No salts going out, no alkalis going out. It only happens if you overdosed your reagent.
So it won't, will it affect the pH of water? If you put it into water with a pH of 7, will it change the pH?
No, if it's a genuine, complete geopolymer, it will not.
Whereas concrete would probably change the pH.
Yeah, because of leaching of this.
Actually, there was, at one geopolymer camp, there was a big study by one of the marine ecologists who have made 2 different geopolymers. They had 2 different goals. One of the goals was to provide a structure which will increase the growth of marine living species, like different algae and different small plankton. And the other goal was a completely opposite: create a stone, a geopolymer, which will prevent this from growing. And both is possible with geopolymer. It only depends on the chemistry and your goal. So you can create either a fish and algae friendly system or absolutely hostile friendly system for them, so it will prevent the growth of this stuff.
Like for the artificial reefs, when I see the project made by 3D printing companies, there are several of them, and they make these artificial reefs out of Portland cement based system, which is not durable in salty water and not so friendly for these species. And I see that geopolymer could be the best material for implementation such projects.
Makes sense if you want to be able to control the pH in the system.
Yeah, and also geopolymers are absolutely stable in either alkalis or acids or salty water, so they're not
We
attacked.
actually can use sea water in our reagent preparation instead of normal water,
which is very actual for countries like Dubai and other countries with where there is
lack
not
of
enough
water.
not enough fresh water.
Does it require the salt content, or you're just able to use either?
We're just able to use it. Will not.
Very nice.
So you cannot use it in Portland cement at all,
because fluorides really destroy Portland cement concrete, while fluorides in geopolymer, they're just trapped and they don't disturb it.
Does the silica come from sand?
No. Sand is in
crystalline silica.
Crystalline silica, it's inert, it's like a filler. So silica has to be amorphous.
So that's more difficult to get than sand, but sand is kind of difficult to acquire these days as well.
Yeah.
Yeah, one more point: in geopolymers, you can use different worse quality sands, which cannot be used in ordinary construction.
Like with a lot of clay.
With a lot of clay or some mine tailings from
industry, metallurgy.
From metallurgy, from copper mining, from steel mining. which cannot be used in Portland cement so much because of the containment of different clays, of different impurities.
Can you
in
use
Portland,
the, sorry.
Yeah, they just increase strength of our geopolymer concrete instead of reducing it.
Can you use the smooth sand from the Middle East, like Dubai?
There is a technique that can use this fine grade sand for geopolymer concrete, and we have already tested, but not, I would say, implemented industrially yet because there was no demand for that.
Yeah, it's interesting. Somebody was talking about, of course you can, they built the earthquakes with that sand, but, or sorry, not the earthquakes, the pyramids, but it wasn't the same sand back then. Like that area was covered by an ocean, that sand got smooth over time. So it's not the sand that they built with, it's the sand of today. But I guess now that we're towards the end of the podcast and very few people are listening, can you talk a little bit more about the pyramid and how Davidovich talks about the pyramid and what the evidence is, I guess?
Actually, he has done some even a full-scale test. He has done an artificial pyramid with the same instruments and with the same materials that could be found in ancient Egypt that he studied. And he replicated a small pyramid in France. And actually, his proofs in his book, he made a book, Why Pharaohs Have Built Their Pyramids with Fake Stones, described very well in pictures, in graphics, in formulas, why these pyramids probably were not made with real stones, but were casted on site. Like, for example, there are some very fine cuts which cannot be done without iron instruments so smoothly. And why would you cut a stone so long and then leave a small turning point, a really small one, in the end? It makes sense, but it makes no sense in cutting with copper tools or stone tools. And then there are traces of some ropes just embedded inside the stone. So it couldn't be made just because they were pulling this with this rope. It's a real trace that it was casted inside. And for example, in South American monuments, you can see small bubbles on the surface of the stone. And you have the same bubbles when you cast your concrete in the mold and then you demold it. On the surface, you have the small pores left. It looks very much similar. And then he also studied some, let's say, objects, small objects like statuettes, small statuettes made out of granite-like rocks in Egypt with very fine, very small holes inside, which couldn't be done without the tools. It can be done now with the tools that we have, but not back then. And then he replicated these stones in France with using limestone, using sand from Egypt, and using limes. Actually, in Egypt, they found the furnaces, they found the kilns where they prepared lime. They said that they used them for smaller structure, not for pyramids. And then they found this lake natron with a lot of alkalis in the natural state, so they could use this lake natron. And then there were a lot of volcanic ashes at the bottom.
What a fascinating puzzle.
Yeah, and he published some articles on the South American monuments recently with his son Ralph, who went to South America to study their rocks, and he proved that there are no source of rock nearby that could be brought to this place, but there is a source of clayish materials of weathered rock, which could be milled and then casted to form this kind of natural looking rock.
I believe they just found a huge city under the rainforest in South America, probably made out of similar material. It's very interesting. They're like the oldest structures, all the oldest structures in the world. But what about the Great Wall? That's not geopolymer?
Actually, they used the geopolymer technique in the Great Wall to cover the stones to prevent them
the stones
from,
and bones.
They actually have burned a lot of rice husk, and rice husk contains a lot of silica inside. And then they covered the wall with this with the solution of this silica, and then they burned it again, and it created like a glaze on the surface of the wall. It's a proven technique actually, and this makes this wall last so long because it creates kind of thin layer that protects the whole structure from weathering.
Okay, what about Stonehenge? That's not geopolymer, is it?
No, I believe these are real rocks.
That was
Not,
real
not all
rocks.
rocks are geopolymers.
Not fake rocks.
Well, it seems like every big object from thousands of years ago, like almost all of them are geopolymers.
Not necessarily. Only if you don't have the source of big stones nearby. If you cannot find a quarry where you could find these monoliths, then probably you should look into geopolymers. But if you see the quarry with traces of monoliths that were taken out, that probably
and you have hundreds of slaves which can treat this quarry and make a stone shiny, then you'd better use this.
And the aqueducts in Rome?
Well, yeah, in Rome they used stones, but as a mortar they used the Roman cement, kind of geopolymer, because Portland cement wasn't known that days, so they used only Roman cement with volcanic ash and lime.
Does all geopolymer use silica?
Actually, we need a balance between silica and alumina to create geopolymers.
So it's impossible to have no silica in geopolymer.
It is possible for phosphate-based geopolymers.
Wow. And maybe other stuff too, or that's the only solution? Is that known?
Maybe, but maybe it is not known yet. Once you can create a three-dimensional mineral chain without organic polymers, and it's a really 3D network, a big molecule, macromolecule, then you can claim that it's a geopolymer.
Does protein folding have any place in this space? Does that help at all? Does that do anything?
Protein?
Yeah, like they're developing a lot of artificial intelligence for protein folding, proteins like nanoproteins. And I imagine it would have some kind of material property impact, potentially. I don't know.
Well, we're not familiar with that.
We're not
protein
into organic chemistry, let's say.
Yeah, just like thinking of things that are unexplored, like maybe I think the way people build in the future, and I think you will agree, is going to be very different than the way people are building now.
Let's say construction industry is one of the most conservative, and it's very hard to bring changes.
3D printing is so big disturbance into this construction industry. They still trying to get rid of this way of construction.
Everything new is very irritating for the construction guys, because really they hold responsibility for the lives of the people. If something collapses, who will be responsible? So that's why it has sense. It makes sense to test and test and test again all your structures, all your materials before you use them on the massive scale.
Rightfully so.
Yeah, but what we have now, the present techniques and technologies of building, they're not very sustainable, and they're very expensive, and they take a lot of time, and still they're not safe. If the fire occurs, we have so many problems with thermal insulation, with steel structures which collapse. So there is a lot to be done yet to make construction safer and better.
There will be changes, significant changes in the way they build the houses.
But it takes a lot of time for the change to be accepted in this industry.
If I was an insurance company, I would love a 3D printed house, because you just put a camera on the machine and you see the whole process. You make sure everybody followed every step. It's not like having an inspector that only shows up to the site once a month or once a week, however often. They can see everything that happened and they can qualify that it was built to spec. It seems obvious, but it's not working for them yet.
Well, now there are techniques and the companies who make monitoring of the construction objects. So they put cameras, and they can even find those construction workers who do not wear helmets.
Yeah.
So they can recognize the people, identify them.
Most construction sites don't allow any cameras because they're afraid OSHA will see what's going on. They say no pictures, We don't want to get in trouble for safety, whatever.
Yeah.
I mean, any construction site is going to have at least one safety issue. You have so many people, not everybody knows all the rules. Maybe one person not paying attention. There's always something that's not perfect. And
Well,
so if you have a camera, you find it.
Even in the 3D printing industry, we are so close to those robotic arms. So people from ABB are not very happy about that.
So we need to really go to more and more automatization of this process so that people don't have to stay in the danger zone.
Yeah. Or ABB could make the robots not touch people.
But they're quite weak for that. They have a collaborative robots which you can stay shoulder by shoulder, but
you need a bigger payload.
Yeah.
But I imagine that's something that would be very feasible with time, like 10 years from now, 20 years from now, they'll have a high payload machine that won't hurt a person at high speeds. Maybe it's with vision or LiDAR or some solution. But since your company knows how to operate that equipment and run the material through, whatever innovations people come up with for the robotic arms, you'll be poised to implement faster than any other company.
Yeah. There is a safety feature that can be implemented. So if person enters the danger zone of the robot slows down, so it will not harm a human.
Yeah, and with time, of course, it will become more and more automatic, and people will stay out of the danger zone. They will be at the control point, not at the printing point.
Maybe one day the people can stay at home and just press the buttons from their computer.
I hope so.
That's where we aim.
Yeah. Very difficult challenge, but not unlikely. I mean, technology moves so fast and in so many different places. Construction has been like waiting for so long. It's like eventually it has to happen in a big way, and it's happening. It's happening.
It is. Even when we started with Apiscore in 2016, for us it was like really in the beginning we didn't believe that this technology will take place, but after we saw Nikita's 3D printer, after we saw that it really works,
proof of technology,
yeah, we were amazed, and we understood that it will be the future of construction, but it will take a lot of time. But even since 2016 till now, there are so many companies, 3D printing companies that have emerged, and there are so many materials that have been developed and used in 3D printing. And it developed so quickly that I really believe that in 5 to 10 years, it will really have a massive scale.
Yeah, very exciting. All right, well, is there anything else we should cover?
Well, actually, there are a lot of, let's say, technical solutions that still need to be found if we are talking about construction of the houses in 3D printing, and a lot of standards that need to be written in all languages in all countries that will allow this technology to be used on a massive scale, and materials which will be approved for this technology. So there is a lot of work that needs to be done both by academics and industries, and there are a whole bunch of industries that will emerge around 3D printing, those who supply materials, those who supply spare parts and stuff like that.
Mixers.
Yeah, right now, for example, we have to 3D print with plastic parts of our 3D printer. So it's 3D printer as well. And I think in the future, it will be more and more automatized and produced on a massive scale, become cheaper and cheaper in application.
Yeah, that's a good vision. The call to action, how do you make those regulations without making them restrictive? Because as we talked about, it needs innovation, improvements, changes. How do you make sure that the rules don't prevent innovation?
They should be performance-based, not, let's say, based on restricting you to certain technologies or materials used.
Method-based.
You should prove, you should prove the performance of your structure or your material or your object or whatever it is. If you perform, if you prove that you perform in the right way, then you're within the standard. Like in Australia, I think that's the best way to allow innovation.
That makes a lot of sense to me. Are you going to run for president?
No, thanks.
Not yet.
I prefer business.
No, of the Concrete Association to make the rules. That sounds like good rules. The construction industry needs something like you said, like to open up the innovation ability rather than saying you have to do it this way, that way. That's like my fear is that they regulate the 3D printed construction industry and then it's cemented in its current state and it's harder to innovate further than that. Like a big company with billions and billions of dollars pays to have kind of unfair regulations so that only they can be competitive or something. I don't know how or what would happen, but hopefully it's something innovative so that everybody can keep making new stuff all the time.
Well, then we need to have a lot of players and a lot of different companies on the market.
There are.
And yeah, and the more there are, the more there is variety in the standards that can be accepted. I mean, there will be more influence from different sides, not just from one side. And then you have to attract universities and institutions and academics who are working not for money, I would say, but for their scientific works, and they will also influence the standards.
Definitely. And they're doing most of the testing in terms of, you were talking about the strength and stuff like that. Not a lot of private companies have the ability to build a whole house just to knock it down and see how strong it was.
Yeah.
Yeah.
Exactly.
And most of the companies don't have so much time to make all these tests. Most of the tests in construction are very, very long term.
Like several years long.
So have you structured your company to give yourselves the time for the R&D process? Is that like part of the plan very much?
Actually, we have done already a lot of R&D since 2015 that we have been formed. And even before, we have our lab since 2008, our concrete and cement lab. So we work a lot in the sphere of R&D as well. So we have been prepared to 3D printing before we started.
So after you finish your house started, and maybe that'll be done in like 6 months or so.
We will see. We are not in a hurry right now, so we try to really work on each detail, on each small part, like how will you realize a window? How are you going to realize a door?
Yeah.
How are you going to put inside your pipes and so on? Now we have figured out several configurations of the panels, which we have already printed. Then to print the next panel, we have to solve another issue. How will be the angle? How will be the corner of the house looking like?
Mm-hmm.
Is it going to be rounded or square or
other shape?
Other shape, yeah, whatever. So there are, each time you go further, you make one more step. There are a lot of different solutions that need to be taken. So it takes a little time, but it's a very interesting work to do.
Of course, yeah.
And then we can multiply to other houses already with a ready book of solutions, of technical solutions. That's what we are aiming to have this kind of book where you have all your parts of your house written down, how to achieve them in 3D printing. We made the same before several years ago for another technology of blocks, of wood concrete blocks. So we want to make the same album for 3D printing for a small house. Then we can multiply it for a multi-story house.
You built the wood concrete house. When you say wood concrete, like using that separately or a unique type of concrete?
It's actually a technology of making blocks out of pressed wood covered with a thin layer of cement.
Nice.
And then it has holes inside, and you can pour ordinary concrete inside, which will hold the load.
And how was that?
Instead of wood, you can use the hemp, which is really durable, strong.
Did you like building that house? It seems like you pursued a different direction.
It was a long ago project, and we built a factory producing these blocks, and we have built multiple houses, not just one house.
Wow. So that was a previous company of yours?
Yeah.
And you still operate that company?
No, we worked for that company until 2014.
Cool.
Let's say as an R&D subdivision of this company.
And in 2014. After that, you went in 2015 to learn with Davidovich about geopolymers, and now that's a fascinating development. You stayed in kind of innovative construction and branched out. Very cool. Before that, what did you do?
Well, since 2008, we've been working with that company.
Before we studied at the university.
Yeah, then before we were finishing our university.
So you went to the same university together as well?
Yeah, the same university, but different faculties.
Wow, you've known each other a long time.
We actually didn't meet each other in the university.
At all.
Wow. And then you worked together and then you started a company together.
Yeah.
And her father was studying alkali activated materials since 1980s.
He made his PhD in 1985 on alkali activated materials. And actually, we used to work with him for R&D and started with alkali activated materials. And then we learned about geopolymers. And the first idea of all these alkali activated materials and geopolymers came from the city we used to live in. It's a very industrial city with a lot of steel industry. So a lot of wastes, a lot of industrial waste, dust, emissions, and so on. And the idea was to use them in construction as much as possible, to reduce the harm that they are making to the ecology. So we're all about eco-friendliness and sustainability. And I'm really motivated when I know that each ton of materials that we use in our geopolymers is 1 ton less in the air in my city.
Very nice. All right. Well, is there anything else we can cover? I like to make sure it's hard to schedule Russia, America, time zones and everything. If there's anything left to say.
Sustainability, actually.
Yeah, have we talked about sustainability?
Well, yeah, the whole idea of geopolymers came from sustainability, for us at least. It's about the use of wastes, about the use of industrial waste in construction, slags, microsilicas, fly ashes, and so on. Everything that's going now dumped to the ground and pollutes water, soils, and so on. And there are a lot of use cases for this kind of materials. And when we learned about geopolymers and we started using them, we realized, and compared to Portland cement, for example, when you bake Portland, when you use your kiln with 1,500 degrees C, you emit about 1 ton of CO2 for 1 ton of Portland cement produced. So it's a huge amount. About 500 kilos is for gas that you burn, and another 500 kilos is for decarbonization process. So CO2 goes out of the stones, out of the minerals when you actually calcine it. And in geopolymers, we take what has already been calcined by other industries like metallurgy, like power plants. So we don't need to burn anything, we don't burn gas. And the only CO2 that is emitted is for transportation of these materials. And we have made a calculation. So it's about 90 to 100 kilos of CO2 emitted for 1 ton of geopolymer cement compared to Portland. So it's 10 times less. And you don't need to invest like 200 billions in a cement plant. You need a quarry for a cement plant. Here, you don't need any of those. You need a small facility and you can produce a geopolymer anywhere.
Very nice.
Yeah, I think I need some water because we've been talking so much.
Yeah, I'll bring it for you.
Sorry.
No worries. Very cool. I appreciate your enthusiasm for the whole thing, and especially sustainability and growing up in a city with those things you can put into the concrete and prevent from entering the atmosphere. I mean, even like you were talking about earlier, it's as adaptable as to trap radioactive waste too.
Yeah, and toxic waste as well.
The city wasn't Chernobyl, was it?
No, it's Chelyabinsk, not Chernobyl. Chernobyl is a closed city. Nobody can live there.
Is it close by?
No, it's like 3,000 kilometers from there.
So you don't have.
It's in Europe. Thank you.
You don't have radioactive waste nearby to test the.
We do. We actually have Yeah, we have a big facility not far from our city, which is very secret and stuff like that.
Not that secret. They have an excursion for American.
Yeah, it's
no
not
problem.
it's not secret for the US citizens. It is secret for our citizens.
Well,
Yeah, and
if you're
they
listening on the
actually-
podcast, don't tell anybody about the secret facility.
No, it's an open information. They actually recycling radioactive waste from the nuclear power plants from the whole world, from Europe mainly, and they make it fuel again.
It's so fascinating how many things can be powered with nuclear, and like a whole submarine can be powered forever with nuclear. It seems like really exciting. One of those things that's like kind of unexplored.
Yeah.
Like, what if a car had a nuclear battery? Would you just have to never charge it and just not crash?
And the point is safety. That's the issue that they have to make a solution with. I don't know if I would like my house to be powered by nuclear under my house, you know? You never know when it will explode.
What if it's in a well? What if it's 1,000 feet under your house?
And then how feasible it is to deliver this energy for such a distance? You will lose a lot of capacity during transportation.
Mm-hmm.
If they find a solution for the transportation of power without losing part of its capacity, then probably it makes sense.
Yeah. If Geopolymer can store nuclear waste, maybe the future can use more nuclear power. Who knows?
Mainly like a sealant, I think, like a coverage for the battery.
The hard part is making something sealing that will last 10,000 years. Then Geopolymer fits that.
Yeah, actually Geopolymer can do that because Portland doesn't withstand even, it goes on the bottom line of the standard for this encapsulation of for the concrete that blocks this waste.
Well, I'm kind of hoping you enable a nuclear energy future with Geopolymers and new construction future.
Yeah, I only hope we will make it a little bit safer than it is now.
Mm-hmm. Maximum safety,
yeah,
maximum power for the people on Earth.
Sounds like a slogan for the presidential campaign.
Well,
no,
you guys
really
are going to be the first podcast in the new studio.
Wow, awesome.
Oh, really? You have a new studio right now?
Yeah.
Where are you, by the way?
I just set up in Houston, Texas.
Wow.
It's good central location so I can bounce around.
I believe it must be very hot right now.
Oh, Texas. Yeah, it's very hot. But I was just in California the last week, visiting a couple companies over there. I'm only here maybe like 30% of the time because I'm visiting so many companies all the time. Will you guys ever come to America?
Yeah, we've been there last year for a month. We travel around the
You went to Vegas?
Coast. West Coast, yeah.
West Coast. We went to Vegas. Yeah, we spent 3 weeks with William, with Geopolymers International, to help him. First of all, we participated in the World of Concrete in summer, in June. And then we helped him with his 3D printer. We helped him with Geopolymer to be 3D printable. And then we made a little trip along the West Coast from San Diego to Seattle.
Very
that
nice.
was really beautiful.
Yeah, the PCH, that highway is beautiful, beautiful drive.
Yeah.
National parks.
Oh,
amazing.
Yeah. And how you treat the nature is amazing. When you have deers walking all around and they feel safe.
Seals.
Yeah,
San Diego.
Sea lions going out.
Yeah.
Yeah.
And nobody is allowed to touch them.
Even the dogs are not barking, you know.
Oh, they'd the seals would win that fight against the dogs, I think. I don't know.
Probably the dogs are wise enough.
Yeah, when if Geopolymers International prints a house, I imagine you'll visit it.
Sure.
I hope so, yeah.
Yeah.
You should let me know and we'll do a YouTube video or something. We'll tour through it and yeah, it'd be cool in person.
Okay.
Next time you guys are in the States or Vegas. Vegas is only pretty short away from Houston, so I would gladly stop by. And always keep me updated if you guys have projects. I'm always happy to share the different projects going on all around the world on my social medias and stuff. So if we stay in touch, and I'm always like tagging the companies and trying to make sure it's as useful to you as possible, like the link in the description for your website. Yeah, hopefully you can grow and keep seeing more innovation in the future.
I think we'll keep posting on LinkedIn and on our website all the progress that we have with our house and other projects.
Yeah.
All right.
Yeah.
Well, thank you for
you so
joining me
much.
today.
Actually,
you.
we have been watching your podcasts and we've seen your podcast about AMT. It was so funny. Yeah, these guys are really not very good in marketing, but you made them famous all over the world.
Really? The AMT team. Which podcast episode was that?
The cat house.
Cat house.
Oh
yes.
yeah. I think that was just a YouTube video, not a podcast.
Maybe
YouTube video. Yeah, correct.
I would like to do a longer form podcast with them. The people's attention spans are so short these days. The podcasts don't get a lot of views, but like you mentioned, maybe you listen to some podcast or video, something. The people who have a longer attention span than a TikTok can actually like learn a little bit about Geopolymers or your company rather than just seeing like, wow, it's printing.
Yeah.
All right. Well, we'll stay in touch and we'll do this again, hopefully with maybe with Alex at some point, and again with you as you continue innovating the future of construction.
Thank you.
All right. Have a good one later on.